Welcome back. In the last video, we wrote a JUnit test for our withdrawal functionality, and I posed you the question of have we covered all the functionality of withdrawal yet? So let's have a look at our requirements. Here are our requirements. So customers can perform withdrawal transactions. That's what we were testing. So let's have a look. Is there anything else here related to withdrawal? I'll let you think about it for a little while. You can pause the video if you like. Okay, if we look at number 5, we'll find that it says an account's balance, a debit account's balance, can never go below 0. All right. Now we're not dealing with separate debit and credit accounts at the moment. We might design that a little bit later in another video, but for the moment we've just got an account that we assume to be a debit account. So what happens when we withdraw more than we've got? Okay, so we need to test that scenario. All right, so here's our test case scenario designed from last time. And so how are we going to test this? Well, let's put the proper requirement in there first. Let's copy this, and we'll just modify this template. Doesn't matter. Okay, so we know what we're doing. Our requirement is a debit account's balance can never go below 0. Okay, so we're just going to do another scenario design. So get balance, we're going to still need to do that. Withdrawing, so we're going to withdraw an amount. Now we need to know when this really isn't good enough. If we withdraw and go into a negative amount, what we really want to do is prevent the balance from going below 0. So we should reject this withdrawal. So we really need another, to keep it simple, rather than throw an exception, we'll just return a Boolean. We can test exceptions with JUnit, but this will be a simpler method. So we'll modify our application design to return a Boolean where true means success. That would be true. Okay. And our count with an initial balance is still valid. Okay, so our design has been modified slightly for withdraw, returning a Boolean. Now the action we're going to do is still withdraw. That doesn't change. We could say a debit account. If you want to be clear, make sure that a debit account exists. Our initial balance can still be 0. That's fine. And our input parameters to the method to withdraw. So if we want to test that, we've already tested that when we withdraw less than the amount, than the current balance, it works. What we want to test is when we try to withdraw more. So our current balance is 100, so if we try to withdraw $101, that should fail. That's what we want to test. All right, so our results. Our expected result, the expected state of the system, our balance should be what? -1? 0? What it actually should be, if it's rejected, it should remain the same as it was before. It should still be $100, and the withdrawal should be rejected by returning false. Okay, so what we should get, rather than just a successful return, we should get false returned. So expected return value is false, which means rejection. Okay, so we've just designed our new scenario. All right, so we're going to go through this little process again, our 5 steps for creating a JUnit test. So back into Eclipse, we need another test. We'll call it test withdrawal, test withdraw rejection. Now I'm deliberately having a naming convention for my tests here. They all start with test. But then the next significant convention in this name is what we're testing, the method we're testing. So we're testing with a withdrawal method, and then there's different ways to test the withdrawal method. So it's sort of a hierarchical naming convention. So test a withdrawal method when it gets rejected. Test a withdrawal method when it succeeds. That should be void. Okay. Okay, now what we want to do is we want to set up our fixtures. Now, it's pretty much the same as this. We could copy and paste that in, except we're duplicating code, and because we're good programmers, we don't want to duplicate code. We want to have that in common, and the way you do that in a JUnit test is by having a setup method with the annotation before all. For JUnit 5, it's before all. Okay. So we really don't want, oops. Really don't want that in there. We want it in here. And that will be the same for this one as well. Now, because we're creating global variables, and it needs to be, we need to do a couple of things. The first thing is we need to define these variables outside the method. Okay, but we don't want to set their values there. We want to let setup do that. Okay, so we just want to declare them as instance variables in the class and then initialize them inside the setup method. Now, JUnit 5 requires these setup methods, these ones that are run before every test, to be static. It'll probably have an error indicating that, maybe not. This is the import, so we'll import that. And looks okay, but okay. That needs to be static, and these need to be static. They should also be private as well. So you should always have private instance variables in your classes. And so the setup method is static, accessing these static variables that are now initialized. Now that's going to be run before every test, so both of these will have those values pre-populated. All right, so let's, we don't want to copy that. Let's, I don't want to be a copy and paste programmer, but I just wanted to get those comments, so we'll just delete that. Okay, so that's what's left for our test. So how about we do this backwards again? So we want to assert equals. And again, we're going to have the, well, now we've got a new withdrawal method which returns a value. So how about before we do this, we fix up the return value for the previous test. So we've now got a Boolean return here. We'll call that result. Okay, so, and we should really be testing that as well. Okay, so so we haven't changed our actual application, which we should. So how about we do that first? So in account, we'll make our withdraw return Boolean to be consistent with our new application design. Yep, and we need to return something in there. So we'll just return true every time, because it's just a dummy application that we haven't implemented yet. So that's all good. And then this should work. All right, so we'll capture our result, and then we should probably assert expected result to be the same as actual result. So that return value is actually the actual result, and as part of our expected results, expected result will be, because this is our first test, should be, we're expecting it to return true, and the balance to be 70. Okay, so we've fixed up that test. So we've modified our account to return a Boolean now, and our first test is now asserting the expected return value of true. Okay, so let's get back to our new test. We can actually copy and paste this. This is going to be identical. Okay, so our expected result and actual result. So expected result for this test, oops, expected result for this one is we expect it to return false because we're withdrawing $101 and we haven't got $101. Okay, and our actual result is equal to the return value, oops, is equal to the return value of the call, and that's all on the same line. So how about we just put that in one comment. So actions and results is equal to our call count.withdrawal, okay, and our amount. How about we be even more specific with our name for the amount and have call it a bad. So it's very clear what this test value is. It's a bad withdrawal amount. And that was actually part of our fixtures. That's a double. So bad withdrawal amount is $101. So that's very clear. Okay, so I think we're done. Okay, so our second test, testing for rejection, is we've got a fixture of a bad withdrawal amount. Let's fix up that typo. Is that typo? No, that's right, withdrawal. So we've got a bad withdrawal amount of $101. So we're going to attempt to withdraw that and capture the actual result, which should be false. So we're going to expect false and we're going to assert that. All right. Now, there's one more thing left to do. The expected balance is 100, according to our scenario. That should remain unchanged. If it goes to -1, that would be a bug. So we want to make sure that that is going to work. So we need to capture that. That'll be the same as the other test. So we can get our actual balance from there. Let's copy and paste that. That's part of our actual results. And our assertion is going to be the same as our balance. We can copy that. And we need an expected balance. So having these variable names helps you not forget to do things, and it makes it much more readable. So another part of our expected results is another double. Expected balance is 100. Okay, so that should remain unchanged from the initial balance here. All right, so that compiles, and so we can run these now. Run the JUnit test. We should have 2 tests now. Okay, and you can see that this is our first test, and our second test, rejection, has failed, which is to be expected, because assertion failed. We expected false, but we got true. We got true because we just returned true inside this withdrawal method, because we haven't implemented our application yet. So both tests fail as expected, which is all good. And so in the next video, we're going to actually implement our account and get these tests passing, which will be fun. And I think that'll finish off our series. Okay, so I'll see you in the next video.